The idea of home is one of humanity's most ancient and powerful concepts. It is more than just walls and a roof. It is a sanctuary, a foundation for families, a cornerstone of communities, and the backdrop to our most cherished memories. For generations, the dream of a safe, secure, and affordable home has been a universal aspiration, a symbol of stability and progress. Yet for millions around the globe, this fundamental dream is becoming increasingly distant. Economic pressures, rapid urbanization, and a growing population are pushing home ownership out of reach. The very methods we use to create our shelters are failing to keep pace, and in doing so are failing our planet. For 1,000 years, the way we build has barely changed. It is a slow, expensive, and incredibly wasteful process of cutting, shaping, and assembling materials on site. Think of a typical construction project, a complex ballet of logistics, manual labor, and heavy machinery, all vulnerable to weather delays, human error, and spiraling costs. This traditional or subtractive method involves taking large blocks of material and cutting them down, generating enormous amounts of scrap. The construction industry is one of the world's largest consumers of raw resources, devouring 40% of all raw materials extracted globally. It is also one of the biggest producers of waste, responsible for nearly a third of all landfill refuse. The carbon footprint is staggering, with cement production alone accounting for an estimated 8% of global CO2 emissions. And this environmental toll is matched by a human one, with construction remaining one of the most dangerous professions worldwide. Faced with a global housing crisis that leaves billions inadequately housed and a climate emergency that demands radical change, this ancient method is no longer sustainable. It is a system that is fundamentally broken. But what if we could rethink the entire process from the ground up? What if we could build our homes not piece by piece, but layer by layer? What if a house could be printed, not built? Welcome to Eco-Innovatech. Today, we are exploring a technology that is set to completely revolutionize the way we build our world. This is the story of large-scale 3D printing, a form of additive manufacturing that is poised to solve the deepest challenges of the construction industry. This technology allows us to construct homes, buildings, and essential infrastructure faster, cheaper, and with a fraction of the environmental impact. Imagine a world where complex architectural design, born in the digital realm, is transmitted directly to a machine on site, a machine that then, with robotic precision, builds the structure from the ground up, extruding a specialized, often eco-friendly material one layer at a time. There is no formwork, minimal waste, and a drastically reduced need for manual labor in hazardous conditions. In this series, we will go inside the incredible machines that are turning digital blueprints into physical reality in a matter of hours, not months. We'll meet the innovators, the scientists, and the engineers who are perfecting the materials and the methods, pushing the boundaries of what's possible. We will journey to communities where this technology is already providing affordable, resilient housing for those who need it most, demonstrating its power to address social inequality. And we will explore the breathtaking architectural freedom that printing unlocks, allowing for forms and efficiencies that were once impossible to achieve. This isn't just a new way to build, it's a new paradigm for shelter, sustainability, and human progress. This is the blueprint for the future. Chapter 1, A New Foundation. Across our planet, a silent crisis is unfolding. The demand for safe, dignified, and affordable housing has reached a critical point, outstripping our capacity to build. by the middle of this century, it's estimated that 3 billion people, a third of the world's projected population, will require new housing, and yet the methods we rely on have remained fundamentally unchanged for centuries. Traditional construction is a complex, often chaotic dance of manual labour, logistical challenges, and immense material waste. It is slow, expensive, and carries a heavy environmental burden, accounting for nearly 40% of global carbon dioxide emissions and a third of the world's waste. This deeply entrenched industry has been slow to innovate, held back by fragmented supply chains and a reliance on age-old techniques. And we have learned to automate factories, connect the globe with information, and explore the cosmos. But when it comes to putting a roof over our heads, we still build one brick at a time, a process that is as inefficient as it is unsustainable. The question is no longer just if we can build more, but how we can build better, faster, more affordably, and in harmony with our planet. What if we could fundamentally reimagine the process? What if we could build not with hammers and saws, but with data and algorithms? A revolution is not just coming, it is already here, rising from the ground up, one layer at a time. The concept of 3D printing, known in industrial circles as additive manufacturing, has been a quiet force for decades, primarily used for creating small-scale prototypes and complex plastic parts. But the true paradigm shift began when engineers and visionaries dared to ask a powerful question. What if we could scale this technology up massively? The result is a new generation of tools that look like they belong in a science fiction film. Today's construction printers are giant gantry-style robots that can span the entire footprint of a house, moving with sub-millimeter precision. Others take the form of highly flexible robotic arms mounted on mobile platforms capable of building complex structures with an almost organic grace. The principle, however, remains elegantly simple. It all starts with a digital blueprint. An architect's design is converted into a CAD model, which is then sliced into thousands of virtual layers. This file becomes the direct instruction set for the robot. Guided by this machine code, a nozzle on the robotic arm extrudes a specialized construction material. With relentless consistency, it builds the walls of a house from the ground up, layer by meticulous layer. This is not just automation, it is the physical manifestation of digital information, turning architectural dreams into tangible reality without molds or formwork. The real innovation, the secret ingredient that makes this all possible, lies in the realm of materials science. You can't simply pour standard concrete into a sophisticated printer. It would clog the system, slump under its own weight, and take far too long to cure. Instead, years of research have led to the development of proprietary fast-setting concrete mixers, often called lavacrete, ink, and or other specialized names. These materials are a marvel of chemical engineering. They must be fluid enough to be smoothly pumped through long hoses and extruded from a nozzle, yet robust enough to be thixotropic, meaning they solidify almost instantly upon settling, bearing the weight of the next layer just moments after being deposited. This careful balance of flowability and rapid strength gain is the core of the technology. The printer moves along its digitally charted path, laying down a continuous bead of this advanced material, creating the inner and outer shells of the wall simultaneously. This process forms a cavity within the wall structure, a design feature that is both intentional and highly functional. This space can be left hollow to create a thermal air gap filled with high-performance insulation to dramatically improve energy efficiency, or reinforced with steel rebar and filled with conventional concrete to meet stringent structural and seismic building codes. It's a system that combines robotic precision with material ingenuity, creating a high-performance building envelope from a single continuous process. The speed of this process is nothing short of breathtaking. A robotic system can print the entire structural wall system of a single-family home in as little as 24 to 48 hours of print time. A task that would normally take a team of workers weeks to frame, sheath, and clad is now completed in a matter of days. The construction site is transformed. The noise, dust, and hazardous waste of a traditional build are replaced by the quiet, efficient hum of a robot. A small crew of technicians oversees the system, managing the digital files, monitoring the material flow, and ensuring quality control. It represents a quantum leap in construction speed and efficiency, drastically reducing labor costs and project timelines. But the benefits extend far beyond mere speed. This technology promises a future of greater design freedom. With flowing curves and complex geometries that are difficult and expensive to achieve with conventional methods, finally liberating architecture from the tyranny of the straight line. It offers a path toward more sustainable building, optimizing material use down to the last drop, and virtually eliminating on-site waste. And most importantly, it holds the potential to address the global housing crisis by making construction so fast and affordable that we can finally build homes for everyone who needs one. This is the story of that revolution, a story of how we are learning to print a better future. Chapter 2, the sustainability revolution, building without waste. For centuries, the story of construction has been a story of subtraction. We begin with large standardized materials, massive sheets of drywall, long beams of timber, uniform blocks of concrete, and we cut, carve, and chip away at them until they fit our designs. This is the essence of a subtractive process. While it has built our modern world, it has done so at a staggering environmental cost. Every cut, every adjustment, every miscalculation generates waste. This isn't just a minor byproduct, it's a fundamental flaw in the system. An estimated and deeply troubling 30% of all materials delivered to a typical building site are never used in the final structure. They become offcuts, broken pieces, and surplus destined for an early grave in a landfill. Globally, this translates into billions of tons of construction and demolition debris every single year, a mountain of our own making that chokes our landscapes and leaches into our soil and water. Think of the embodied energy in that waste. The carbon emitted to manufacture the steel, fire the bricks, and transport the lumber, all for it to be discarded without serving its purpose. It's a linear model of take, make, and waste that is profoundly unsustainable in a world of finite resources and a changing climate. But what if we could fundamentally rewrite this story? What if we could build not by subtracting, but by adding? This is the paradigm shift promised by construction 3D printing. It flips the entire model on its head. 3D printing is an additive process, a concept elegant in its simplicity and revolutionary in its application. Instead of starting with a block and cutting away, we start with nothing and build up, layer by meticulous layer. The robotic printer, guided by a precise digital blueprint, places material only and exactly where it is needed. There are no offcuts, there is no sawdust blanketing the site, there are no shattered sheets of wasted drywall. The process is so precise that on-site construction waste can be reduced by over 90%. This isn't just an incremental improvement, it's a quantum leap in material efficiency. The digital model is the ultimate authority, ensuring that every gram of material contributes to the final form. This near zero waste approach represents a seismic shift for the industry's environmental footprint. By eliminating the vast majority of material waste, we drastically reduce the demand for virgin resources and the energy required to produce them. The impact echoes down the entire supply chain. Fewer materials need to be manufactured, transported, and ultimately disposed of. The construction site transforms from a chaotic zone of waste generation into a clean, efficient, and digitally orchestrated manufacturing space. This level of resource stewardship is no longer a futuristic ideal. It is a present-day reality, and it is a game changer. But the sustainability revolution doesn't stop at waste reduction. It extends to the very chemistry of what we build with, opening up a palette of materials previously unimaginable for large-scale building. The precision of additive manufacturing is unlocking a new world of sustainable materials, many of which were impractical or impossible for traditional construction. Researchers and innovators are in a global race to perfect new greener printing mixes. Some are developing printable construction materials from shredded, recycled plastics, creating a powerful circular economy solution that turns our global plastic waste problem into a durable building solution. This process not only diverts plastic from oceans and landfills, but also locks it into a long-lasting, useful form. Imagine homes built from the very packaging we once threw away. Others are tackling the single largest industrial emitter of carbon dioxide, cement. They are pioneering biocements, which use microorganisms to bind minerals together in a process that mimics how coral reefs are formed, and geopolymer concretes. These remarkable materials replace carbon-intensive Portland cement with industrial waste products like fly ash from coal plants or slag from steel mills. This is industrial alchemy, transforming one industry's hazardous byproduct into another's high-performance building block, sequestering waste and cutting the carbon footprint of concrete by up to 80%. Perhaps most poetically, some pioneers are looking to the ground beneath our feet. They are printing with materials made from local excavated earth, mixed with natural fibers like straw or hemp for reinforcement. This approach, a high-tech evolution of ancient rammed earth techniques, creates structures that are not only sustainable and incredibly low cost, but are literally born from the land they stand on. They offer superior thermal insulation and breathability, creating healthier indoor environments that require less energy for heating and cooling. And at the end of their life, they can simply return to the earth, leaving no trace. 3D printing isn't just changing how we build, it's fundamentally and profoundly changing what we build with, paving the way for a truly circular and regenerative built environment. Turn chapter 3, the social impact, printing for humanity. The speed and low cost of 3D printing are not just about commercial efficiency. They have the potential to solve one of humanity's most pressing problems, the lack of safe and affordable housing. Over 1 billion people worldwide live in inadequate shelter. Non-profits like New Story and Icon have partnered to build the world's first 3D printed communities in places like Mexico and Texas. They have proven that they can print resilient, dignified homes for a fraction of the cost of traditional methods. These homes are not just cheap, They are built to last, engineered to withstand hurricanes and other natural disasters. In the wake of an earthquake or a flood, where thousands of homes can be destroyed in an instant, a fleet of 3D printers could be deployed to print new permanent housing for entire communities in a matter of weeks. This technology is becoming a powerful tool for disaster relief, offering a path to recovery that is faster and more sustainable than temporary shelters. It is a technology that offers not just shelter, but hope. And Chapter 4, the freedom of form, Anima, the new architectural language. For centuries, our architecture has been dominated by straight lines and flat walls. This is not because they are inherently better, but because they are easier and cheaper to build with conventional methods. Curved walls and complex shapes are prohibitively expensive. 3D printing shatters this limitation. For a robot, printing a straight line is no easier than printing a graceful curve. This technology liberates architects from the tyranny of the straight line, allowing them to design buildings that are more organic, more efficient, and more beautiful. Walls can be curved to optimize airflow for natural cooling. Structures can be designed with complex, nature-inspired geometric patterns that add strength while using less material. 3D printing is not just a construction tool, it is a new artistic medium, giving birth to a new architectural language that is more in tune with nature and human creativity. So Chapter 5, the challenges and the road ahead. The 3D printed revolution is here, but the road to mainstream adoption is still under construction. Building codes and regulations written for a world of sticks and bricks are struggling to keep up with this new technology. There is a need for new standards and testing to ensure the long-term safety and durability of these printed structures. The technology for printing multi-story buildings is still in its early stages, and integrating plumbing, electrical, and other services into the printed walls is a complex engineering challenge that is still being perfected. Furthermore, there is a legitimate concern about the impact on jobs in the traditional construction industry. This transition will require a massive effort in retraining and upskilling the workforce, shifting jobs from manual labor to overseeing and maintaining these complex robotic systems. The simple act of building a shelter is one of humanity's oldest endeavors. For too long, it has been a process defined by waste, inefficiency, and inequality. 3D printing offers a new path forward. It is a vision of a world where safe, sustainable, and beautiful homes can be built for everyone, not just the wealthy. A world where our buildings are created with minimal waste and are designed in harmony with their environment. This technology is a powerful reminder that our most entrenched systems can be reinvented. It proves that with ingenuity and ambition, we can solve our oldest problems with our newest tools. The robotic arm of a construction printer is not just laying down layers of concrete, it is laying the foundation for a more sustainable, equitable, and inspiring world. What do you think is the most exciting application for 3D printed construction? Let us know in the comments. For more on the innovations that are building our future, subscribe to Eco Innovatech. Thanks for watching.